Alright, this video is going to be about the electromagnetic spectrum. And so electromagnetic waves are made by vibrating electric charges, and these are sort of interesting waves because they can, that shouldn't be gravel, that should be travel, silly me. They can travel through space where matter is actually not present. So these are not like the mechanical waves that we've talked about in the past. They can travel through space and they do not have to have a medium to travel. And so instead of transferring energy from particle to particle like mechanical waves do, electromagnetic waves travel by transferring energy between vibrating electric and magnetic fields. And so the energy carried by an electromagnetic wave is called radiant energy. And electromagnetic waves have a wide variety of frequencies that they can be at, and so we have the electromagnetic spectrum, which is basically the entire range for our part, or for our knowledge about the electromagnetic wave frequencies, okay? And so here we see the electromagnetic spectrum, and we have these sort of long wavelength, low frequency waves, and then we have really high frequency, short wavelength types of waves. And so I'm going to go through all of these here, and I'm going to start on the left of this image and move to the right. So I'm going to start with the longest wavelengths and move to the shortest, or low frequency to higher frequency. So radio waves are going to be low frequency electromagnetic waves with wavelengths longer than 1 millimeter. So these are going to be, when you think of like FM and AM radio waves that allow sound to travel to your radio, those are going to be these very, very long waves. And in fact, if we were going to sort of put this on a scale, FM wavelengths are shorter than AM wavelengths. AMs are really long, which is why you can sort of get AM channels for a longer range than you can FM channels. Microwaves are going to be waves that are about 1 centimeter to about 20 centimeters long. Okay, they are widely used for communication, so for example cell phones, satellite signals, all of those things, and of course they're used in microwave ovens, which you think of a microwave, and so microwave waves will actually heat food when they interact with water molecules in food, which is why when I would make certain things at my house when I was younger, my mom would frequently tell me to put water in the bowl or the container before microwaving it, because the water is actually what heats up, not the rest of everything. Infrared waves are going to have a wavelength between 1 millimeter and 750 billionths of a meter. And so this is how some remote controls actually work with TVs. They might use infrared waves. And when you get like thermal energy from a fire, thermal energy is going to be infrared waves. And so hot objects will emit more infrared waves. And so you can sort of have like heat vision, so you can sort of see especially living things at night. And so the how hot or cool something is will change the color here of this individual based on how much thermal energy, how many infrared, what type of infrared waves are coming off of them. And our visible light spectrum is actually in our electromagnetic spectrum. So visible light is the actual range of waves that we can detect with our eyes. So they range from really long wavelengths, which are going to be red here, which is why they're on the left portion. These are long wavelengths, longer wavelengths. And then shorter wavelengths of the sort of the blues and violets. And when all colors are present, you should know this sort of by now, you see them as white light. So when you see all colors, it's just white light. But when you see different colors, you're actually seeing slightly different wavelengths. And you'll notice here, if you look at the lengths that they have, these range from 700 nanometers to about 400 and so, maybe a little less than 400 nanometers. So it's really a difference of 300 or so nanometers, and that's the whole amount of all of the colors that we see with our eyes. So it's not a very large piece of our spectrum. Ultraviolet waves have wavelengths of about 400 billionths to 10 billionths of a meter. They're very energetic. They're energetic enough to actually enter your skin cells, and that's where you hear that UV rays, which would be ultraviolet, Overexposure to UV rays can actually cause skin damage, can cause cancer. That's why somebody as pale as I am, definitely, I like pour or a sunscreen on myself or like dip myself into a vat of sunscreen before I go outside in the summer. Because I am very, very pale and UV rays can definitely damage my skin. Though, interestingly, some minimal long length UV rays, so that would be the UV rays that are sort of closer to visible light, they will enable your body to actually make vitamin D, which is needed for your healthy bones and teeth. And this is sort of why you end up hearing, oh, there's UVA, UVB, all these different types of UV rays. There's actually a range of ultraviolet, and different rays within them can be better for you and other ones can be bad for you. Moving further into higher frequency, short wavelength waves, we have X-rays on our electromagnetic spectrum. X-rays are going to have a wavelength between 10 billionths of a meter and 10 trillionths of a meter, so definitely getting really small here. We use X-rays, obviously, to form images of internal organs, bones, teeth. My mother's a dentist. She'll definitely take X-rays of my teeth every now and then. And they're used in airport screening devices. I don't know how, to examine luggage. I don't know how current that is, because I'm sure all of our airport screening techniques have definitely been updated over the years. But I'm not sure if they still use X-rays, but I think we've all sort of seen images like these looking at bones using X-rays. And last, over here in terms of the very high frequency, very short wavelength waves are going to be gamma rays. Gamma rays are going to have wavelengths shorter than about 10 trillionths of a meter. Very, very, very short wavelengths. And these are very high energy electromagnetic waves. They have so much energy that they can actually penetrate through several centimeters of lead. And so when certain people are afraid of like nuclear radiation in terms of like nuclear fallout, if there was to be a nuclear bomb or something were to happen to a nuclear power plant, you're very frequently afraid of gamma radiation because these are things that, you know, not just wearing clothing can protect you from, or not just hiding in your house made of wood or whatever can protect you from. This can really go penetrate through stuff. And it's used actually in radiation therapy along with X-rays to kill certain disease cell in the human body. So if you were to look up radiation therapy for cancer, they might use gamma rays.